All right, it's been a while. New problem. Day 53, the subsets problem. And this is a statement. We have an array of integers, nums, and we need to find all possible subsets of nums, including the empty set. And the solution must not contain duplicate subsets. You can return the solution in any order. And this example will make things clear for us. So we have this number, we need to return all subsets, all possible subsets. So these are them. This is how it looks. An empty sets, each individual element in the array, and then this paired with everything individually, and then everything, the original inputs. I don't know if that's clear. You can see another example here. So we have 2 and 4. It should be clear now. You have the empty set, you have the complete set, then you have each individual item like that. If you have 9, the empty set, and just 9, empty set is the empty set. All right. So I think it makes sense. It's a LeetCode medium. There's a LeetCode medium. So you know you're in for a little slightly more work than usual. All right. So let's walk through the solution together. So let's say you have these 3 numbers. I want to generate 2, 5, 7. I want to generate all the possible subsets of 2, 5, and 7. The formula you can use is 2 raised to the number. So there are three items. So 2 to the power 3. We know there will be 8 subsets. Now we're going to use the binary representation of numbers 0 through 8 to create our subsets, right? And you'll see why in a second. So the size of the given subset is 3. So 2 to the power 3 is 8. So 8 subsets will be formed, and the value of I will iterate from 0 to 7, right? The output set is currently empty because the first thing is 0. So you see right here that we start with an I of 1, I of 0. So 0, 0, 0 is the binary of I. So no integer is picked from the given set. And the empty set is added to the output set. So nothing, 0. We're going from 0 to 7, 8, which is 8 different numbers, right? From 0 through 7, 7 inclusive. So we have 0. So the first subset, just like in the example I just gave, is going to be 0, an empty set, nothing. Now, number 1, I goes to 1. And now you have 0, 0, 1. So we see what's at 1, right? In this case, we're going to count from here, right? So the first thing in the array 2. So that represents 2. So we add 2 to an array. Next, 2 in binary is 1, 0, right? If you remember your binary to decimal conversions. And so that's like prerequisite knowledge for this. Otherwise, you wouldn't be able to solve this ultimately. At least I believe so. I'm assuming so. And so we pick the middle thing because now you have 0, 0 on both sides and 1. So that's why we pick 5. So 5 is next. And so on. 3 is 1, 1, right? 3 is 1, 1. So we pick the first thing and the second thing. All right. And we just keep going. And we can do it the other way, right? We can do it the reverse, right? In the reverse way. But it's going to give us the same thing. And so we just keep going. This is 4. 4 is 100 in binary. And it just keeps going. We pick 2 and 7, right? We pick 2 and 7. And because there's 0 here, we skip 5. And so on till we're done. And that's all. That's all to the problem. Now, because we're using binary operations, it's a bit more involved than other things we've worked on. And I'll show you the code in a second. I'll switch back to this diagram from time to time to walk through things. So we pass in the number array, right? And this is the set we're going to return at the end of the day, which is an array of numbers. So while if there's nothing in the array, if it's an empty array, I would just return an empty array because the set, all subsets of an empty array is just an empty array. So we've handled that edge case. Otherwise, if there's something in there, we did a subset count. So 2 to the power of the length of the array. So if there are 3 items, 2 to the power 3, we're expecting 8 subsets. And so we loop from 0 to 1 short of that, which again, you remember from the diagram I just explained just now. And yeah, we have a subsets, the subset we're going to add and return at the end of the day. And we begin some heavy lifting. All right, so stay with me. So now we're looping through a loop inside a loop, right? And we have a loop inside a loop, and I'm going to loop through the total possibilities. There are 8 possibilities, right? So from 0 to 8, right? Excluding 8. And then inside that loop of the total number of possibilities, we are going to loop through each thing in the array. So let's say there are 3 items in the array. We're going to loop through each one, kind of like this, loop through each one. So we're going to loop 8 times in this case. And in each of the 8 loops, we're going to loop through every single thing in the array. So 3 times again. And what are we going to do there? We're going to check this get bit function. Does a lot of the heavy lifting. It checks for that particular possibility. So let's say it's the first possibility, and the particular element in the array we're evaluating. If in the binary positioning we have a 1, right? Just like when we're looping through this, right? In the binary positioning, if we have a 1, right, and it's not already in the subset, then add it to the subset. And when we're done with that, if the list is always going to have an empty array, we're going to push what we have from that subset into our result and return it. So I'm going to look into this function because this does all the heavy lifting. And you can pause and rewind what I just said as often as you want, or find the code in the description and step through with a debugger, as I've done in other videos. But this get bit function, it's a big deal. It's kind of a big deal. Let me make this guy go away. And what you see here is, okay, we have a number, which again, I, in this case, it represents the possibilities. So a number, in this case, from 0 to 7, in the case of this array, 257 array, right? And we have a bit, that is what position, which represents what position, its position in the array, whether it's the first bit, the second bit, or the third bit. So 2 is the first bit, 5 is the second bit, this is the third bit. So when we had 1 in the first bit, for instance, it took the first element of the array, right? When we have it in the second bit, like position here, it takes the second element. In the third, it takes the third element, and so on. So we have the bit, and what do? We do a binary shift to the left. So if bit number of times, so if bit is 1, it's going to shift 1 will become 10. If bit is 2, 2 will become 100. If bit is 2, 1 will become 100. That's what this does, right? That's what this does. It's crazy. I had to use ChatGPT to explain it. So what happens is I pass in a bit. Let's say the bit is 0, right? So it's not going to shift it. So the temp becomes 1, right? That's what temp becomes. Temp becomes 1. And now this second line also is also a bitwise operation. So what it does is it converts this to binary and this to binary, and wherever there's an overlap, it stores it as temp. So let's use this. So hopefully I don't have to pull out a whiteboard. This bit is 0. This is the 0th bit, right? If we're going to make all of these bits. So in this case, bit is 0. So temp is going to be 1, right? And you can think of 1 as 0, 0, 1. Kind of like this, 0, 0, 1. Yeah? Now, that's what temp is. Now, number, on the other hand, in the second case, right? In the first case, number is 0, right? Which in binary is 0. In the other case, number is 1, right? 1. So we have 0, 0, 0 and 0, 0, 0. And because in each position, 0, 0, 0, and in the number we're considering, 0, 0, 0, 1 matches. They're the same. And so we're going to get 0, 0, 1 here as what is stored in that instance. And so basically saying if that works out, if we get a positive number here, that's something other than 0 here, then it means that number we passed in, whatever it was in that array, should be in the current set. And so we add it to that set down here with j, right? Index at j. And that's all this does. And once you do that, you're done. You have your solution. So maybe not my best explanation ever, but I personally needed to sit down and think about it quite a bit, and even step through with a debugger and use ChatGPT to explain all this. I'm using this edit thing called cursor, so I can just highlight something and say chat cursor.sh, and then say, oh, explain this, and it gives me the explanation. And that's how I was able to fully understand what these two lines, these mystical lines that you don't see in day-to-day programming, what exactly they do. Okay, you can do the same thing. You can just paste it in ChatGPT and it'll give you the same explanation. So yeah, that's all there is to this problem. Before we go, let's look at the time complexity and space complexity, and it's exponential. It's an exponential equation, O of 2n times n, because 2n, because you have to loop through 2 times the length of the array, right? The number of elements in the array. You have to loop through that at least once, and each time you loop, you have to loop through each element in the array again. So that's why they got this time complexity represented by this loop, right? So you, first of all, you do 2 to the power length of the array, items in the array, and then in each one you loop through each element in the array at least once. So that's why, that's what that is. It's exponential because this 2 to the n overwhelms this linear time you're seeing, time multiplication you're seeing here. So this wins out pretty much. It's infinitely larger, so much larger than this, like in the grand scheme of things. And the space complexity is O of n, which is nice. It's the number of integers in the given array. So because you never have any more than n things in your subset. You never have any more than 3 things in your subset, right? As opposed to like your results that is actually going to be 2 to the power n, right, in size. So yeah, that's all. At least 2 to the power n in size. So that's all with this problem. Ciao. I need to go.